Now, the interesting thing, and an interesting question is what happens to the L2 that was settling all of the transactions on Bitcoin? That's a very valid question. So over there, what I would say is that the way to slice this is there are two types of transactions on the L2. One are L2 internal transactions, meaning that they're not interacting with or they're not reading any state from the L1, right? So it's an L2 transaction. Like a perfect example would be an NFT mint, right? Or someone likes a meme coin and going after it. It has nothing to do with Bitcoin L1, right? Versus there are other types of transactions that have are reading Bitcoin state or somehow interacting with Bitcoin state. Example would be someone is trying to peg in BTC into the L2. Or let's say you link DLCs, discrete log contracts on the L1 with the L2, and now the L2 contract is actually watching the state of the L1 contract. Now, if a Bitcoin fork happens, the two different types of transactions actually behave differently. The ones who were impacted by the Bitcoin L1, they are obviously going to change because Bitcoin has changed underneath, right? And so you have to wait for Bitcoin finality on those transactions to be very sure that they're going to sort of like not change, even though the frequency of the changes is very low, like once every week or something. It's safer to still wait if you know what type of transaction it is. But the internal L2 internal transactions are actually different because the validators have already signed on like what was the total ordering of these transactions. Even if Bitcoin forks, they can have a policy to just replay those transactions in the same order, right? So users are not going to care that, hey, which Bitcoin block did my transaction settled in, as long as, you know, if a fork happened, very quickly this again see a confirmation with the same order that things got confirmed in the first place, right? So it would be like a switch in the Explorer, then instead of this Bitcoin block, now you're in the other Bitcoin block, but the order of the transactions sort of like remained the same. So that's I think in some ways is a very low level detail, as something that would be handled by the validators and the miners, but users might notice it. Oh, I thought my transactions went into this Bitcoin block, but now they're actually went into some other Bitcoin block. But in the grand scheme of things, you don't care because the ordering remained the same and your transactions still sort of get in. And as far as the transactions are concerned where they are reading Bitcoin state, I would point out that that's the theoretical best thing that you can do. You can never do better than Bitcoin finality on those things, regardless of which L2 you're on, regardless of even what L1 you're on. If there's an L1 contract, let's say Ethereum, that is trying to read some state from Bitcoin L1, if the Bitcoin L1 changes, it's going to invalidate what was happening on Ethereum, and they'll have to adapt. If anything, Stacks is so focused on Bitcoin and with close connectivity to Bitcoin, everything watches Bitcoin, and our focus is to make these types of transactions as easy to do as possible. So we're looking in certain work where you can do an analysis of these transactions at the VM level, and even display in Explorers that, oh, this transaction, you might want to wait for Bitcoin finality, right? So just educating users more, right? That, hey, you're interacting with Bitcoin L1 state here, you might want to actually wait for Bitcoin confirmations, which I think again is the theoretical best you can do for that type of transactions. Hope that makes sense. I think another point that I want to make in terms of the upcoming Nakamoto release and so on is that the overall sort of like mindset that a lot of the open source developers are in right now is that they want to ship the critical or the hard sort of like technical things with the Nakamoto watch, right? So for example, decoupling the fast blocks from Bitcoin blocks. That's a consensus level change. That's a pretty big change. Or introducing Bitcoin finality, that, hey, everything now depends on Bitcoin finality. Stacks doesn't have its own security budget, and so on. Other improvements are around like, hey, there's some sort of a Bitcoin MEV that's possible right now. And I think those vectors are removed. And in many ways, like the chain becomes much more secure. Mining becomes more competitive. Even Bitcoin yield can go up, like when Nakamoto launched it. But these are like fundamental consensus level things that will give you sort of the fundamentals and the foundations for doing future performance improvements, right? And in terms of future performance improvements, the sort of mindset to have in mind is that they can ship with any node upgrade as well, right? Because once you have decoupled the L2 blocks from the L1 blocks, which is the hard part, you can always ship an upgrade to the normal node in terms of optimizing certain code so that latency becomes even smaller, right? Those are not hard things. Like these are more typical distributed systems type of problems, whereas consensus related things are the really, really hard decentralized systems problems. So I think what the developers are focused on is what are the core critical things that have to be shipped as a hard fork. Let's get all of that live, and then we will keep improving on the latency, on the throughput capacity of the system with every sort of like software upgrade that goes live. And I sort of like really like that framing, because even in the long term, even sort of like a year from now, 2 years from now, there will be advancements in our industry, in other blockchains and so on. Let's say someone comes up with a faster way of propagating blocks, right? We should be able to take that and implement it on a Bitcoin L2 and benefit from those types of improvements, right? So whatever, going back to the theory that the best experiments in crypto would eventually make their way to Bitcoin, I think that this is true for Bitcoin L2s as well. If other systems outside of Bitcoin are becoming faster, cheaper, whatever the property is, I think stacks can keep incorporating some of the best of those technologies and keep getting faster, cheaper, and so on.
All right. Thank you so much for going in depth there. Now, we got a little bit into what could be around the corner, but I am curious about how are you viewing the longer term roadmap for stacks and as it continues to grow as the Bitcoin layer?
Yeah, so I think this is again something where decentralization kicks in. That one of the reasons why some people have seen some community members like, hey, why isn't there like a clear roadmap of like what's going to happen? Well, it's a decentralized community, right? Like people need to come together and agree on what direction we want to go in together as a community. But again, that doesn't mean that you're not going to have a roadmap, right? Like decentralized doesn't mean disorganized. That means that there's a process. People can participate in working groups and put out proposals and sort of like hash it out. So I would give a view of like the near-term things. I think there's more community consensus that, hey, that's going to happen. The further we look in the timeline, I think my views become more personal, right? Like my ideas for like what might happen. So let's keep sort of like that in mind. So I think things that are much more concrete, the Nakamoto hard fork already has SIP out. I think actually voting is going to happen on that soon, but strong support from the community right now. Then we are looking at SBDC and WASM as two other big things, right? So WASM is a big thing because of two reasons. One is that it will make clarity faster, which actually translates to more network capacity. Like it's actually not obvious to a lot of people that why would WASM mean more network capacity. The reason is that if contracts are executing faster, you can package more contracts in the same block, right? So people would notice the difference by seeing just more transactions in the same block, not that you would notice the speed difference of contracts actually executing faster. So
for those that are non-technical, what is WASM? If you could
WASM is basically WebAssembly, right? So think of that as it's a standard that emerged where you can compile higher level languages into WebAssembly, right? So let's say you want to program in Rust or you want to program in something else, you can actually compile it down, and it's actually emerging as a pretty strong standard just outside in the tech industry, outside of crypto as well. Like Google is behind it, and a bunch of other folks are behind it. So when you compile your programming language into WASM, because WASM is so optimized, your programs actually become faster. But it's not just about faster; it's such a big standard that then there are benefits of the standard as well, because so many people have integrated it, so many people understand it, people know how to run against WASM and so on. Think of it this way, that if EVM is becoming a standard within crypto, WASM is already like a much bigger standard outside of the crypto industry. And I think bringing it into the tech stack for stacks is actually very interesting, because now there's a widely accepted standard from the Web 2 world, which gives you massive performance improvements that you can start working with. So it will make Clarity faster, right? But here's the interesting part. It does open the door to potentially other languages as well, right? Like sometimes we do get the question from developers that, hey, I actually know Rust or really like Rust. Can I program in Rust? We will tell them like Clarity is safer, but people are like, hey, I just want to get started, right? Like I just want to quickly get started and I already know this language, or maybe I know Solidity. So I think it opens the door to some of those things. Again, it might be further down the road, but definitely I think if WASM goes live, which is the plan in one of the hard forks, then it opens that door, which I think is very interesting, because there is something to be said about more developers coming in and building on a Bitcoin L2. And once I think they realize that Clarity is safer, they can always upgrade their contracts to Clarity, right? So it just gives you a bigger funnel of more developers sort of like coming in, and then Clarity's safety benefits are still there. To be more specific, I think Clarity contracts that only interact with other Clarity contracts would have the sort of like bigger safety features. But if you start interacting with the non-Clarity contracts, you lose some of those features as well. But those are like technical details that we can get into. So I think that's one big thing. SBDC is obviously a really big thing. And then something that I just mentioned, that there should be more of a steady stream of performance improvements, right? Where we have optimized the code somewhere and now latency is even better, right? Like whatever the latency was, it sort of like goes down even more, or the network capacity becomes better. And I think as the project is maturing, getting on some sort of a cadence of hard forks, that let's say every 6 months or whatever the timeline is, there's a hard fork where more consensus critical upgrades happen, but getting to an even faster cadence of just node upgrades, right? Like, hey, here's a new node upgrade that shipped, just upgrade your code, and you get to have like certain performance improvements. So I think that'd be great to see. After that, I'm personally very excited about tighter connections with the L1. So there are certain tooling on the L1. For example, BitVM is a newer one that can actually reduce the trust assumptions for how you move BTC from L1 to L2. I think that's a big area of R&D that could be super interesting. Another one is DLCs, the discrete lock contracts, because they're more advanced scripts on the L1. You can lock capital in DLCs and have some logic around it. But tightly integrating that into the Stacks L2 is, I think, another open area for R&D that could be super interesting, and again, something very, very unique to Stacks. Right? Like the way Stacks is designed, you're already reading all of the Bitcoin L1 transaction, so you already know what the DLCs are doing. And I think there can even be benefits to DLCs if they get a tighter integration with the L2. Further, I think one of the things that I think would be super interesting is you can't have rollups on Bitcoin L1 directly right now. Like, I think there are ways to do it, like sovereign rollups and some other approaches. But in terms of a very expressive smart contract that you can write that can just port, let's say, something like Arbitrum to Bitcoin L1 directly, that's very hard to do on the L1 level. But you can do it at the L2 level, which still has a lot of benefits, right? Like, so imagine that, Arbitrum or any other sort of like L2 from Ethereum, someone wants to port that over to Bitcoin. I think once BTC is sort of like living in Stacks L2, you can actually port that to the L2. It's sort of like running as an L3 if you want to conceptually think about it. But you can start moving BTC capital in there, which I think is something very interesting. Another thing that's on my mind is the concept of Bitcoin subnets. So I know Hero Systems has done some work on subnets already. For people who are not familiar with this, if you're familiar with Avalanche, the way Avalanche is designed is there's a main chain, they call it the C chain, and then there are subnets, right? Which are more localized, sort of like smaller networks that interact with the main chain. And one of the benefits of subnets is that you can have more permission networks as well. Let's say you're a gaming company and you want to have more control over your subnet. You can do that, but you're still interacting with the main C chain. And with Bitcoin subnets, you can sort of, instead of connecting to the C chain, you're connecting to Bitcoin L1. But again, not directly through the Stacks L2, but all of your state is still settling on Bitcoin L1. you're also getting your liquidity from Bitcoin L1 through the L2, but into the Bitcoin subnet. And I think that's a very powerful idea, because there are so many organizations, think like BlackRock or whatever, who are going to be thinking about tokenizing assets or other sorts of applications. And the pitch to them is, why not go for Bitcoin liquidity and Bitcoin settlement, right? Because you want to control the environment, that's your Bitcoin subnet, and then your settlement is happening on the Bitcoin L1. So I think that's a very interesting thing. I know there's a version of subnets that's already live. Probably I think 1 or 2 parties are running it, but it's not a focus right now. But it's a more like, how do you properly package it as Bitcoin subnets and iron out some of the details of how BTC is moving into the subnet, how settlement is actually happening, how to make it easy for new players like gaming companies or other large organizations to boot up their own Bitcoin subnets. Could be very interesting. The analogy here is really, I think, at the early days of the internet, there were many different types of internets, and then there was the internet. I think Bitcoin is sort of like the network, but then there are these LANs or local area networks. If you are working at a large office, you're on a local area network where the rest of the internet doesn't have visibility into your local area network, but you are connected to the public network. You can access the internet. I think Bitcoin subnets are like that, where you can keep certain things permissioned and more private to yourself, but the subnets can benefit from being connected directly to the public Bitcoin network. I think that's a very, very, very powerful idea. So I would summarize things as, on the roadmap, I definitely think some of the rollups type technologies coming to stacks in various formats. In the very long term, like if rollups really take off, I think you can even think of like stacks evolving into something like a rollup. I don't want to put too many ideas in people's brains, but this is like thinking very long term, because in some ways stacks is closer to a rollup in some of the security properties, like in terms of the Nakamoto release. It has the reorg resistance of Bitcoin. Stacks doesn't have data availability on Bitcoin L1, like how Sovereign rollups do it, but you can verify all the data from L1. All the hashes are on the L1. So we picked a slightly different trade-off, that we think writing all that data to L1 is going to be very expensive. So the data remains at the L2 level, but you can verify all the data by just using Bitcoin L1. So I think there would be other tweaks and other advancements in rollup technologies, and I can totally see more R&D happening and some of those getting absorbed in either the core design of Stacks L2 or these extensions that I was talking about. So I think those are some of the items. I don't know what the ordering is, because as further we see, like in year 1 after launch of Nakamoto, 2 or 3, I think the less clear things become, the hey, exactly when something is happening or not. But I'm pretty sure that as soon as Nakamoto launch is done, there's a lot of brain power in the Stacks ecosystem, and I think people are going to start thinking about, okay, what's the next big thing? What's the next major thing that the open source community is working on?
Well, thank you. That was a comprehensive overview. There's a lot to dig into, and thank you so much for being here. I know that you are covering a lot of ground at events, and that's oftentimes why we have a little bit of delay in Stacker Chat. So we'll definitely try and do them more frequently heading into this new year. And thanks everyone for tuning in. Please like this video, subscribe for more content like this and more updates. And let us know if you have any questions or comments below. Thank you so much.
Awesome. Yeah. And a belated happy 2024 to everyone. Thank you.